Deep in the darkness of interstellar space, a machine launched nearly half a century ago is still moving. It is currently more than 13 billion miles from Earth. Reaching the outer solar system is usually a slow process. To reach Neptune on a direct path using standard rockets, it would take 30 years. But in 1965, engineer Gary Flandreau identified a rare orbital configuration. In the late 70s, the 4 giant outer planets would align in a specific arc, an event that happens only once every 175 years. This alignment allowed for a gravity assist. A probe could use the pull of one planet to slingshot toward the next, increasing its speed and cutting the travel time down to just 12 years. To meet this window, NASA launched the twin Voyager probes in 1977. They were carried into orbit by Titan IIIe Centaur rockets, beginning a journey to the edge of the Sun's influence. By timing the launch to this orbital loophole, humanity began a mission that remains the most distant exploration of our solar system. Before 1979, our best views of Jupiter were distant and blurry. Voyager arrived to reveal the Great Red Spot as a violent counterclockwise storm system filled with complex eddies and smaller tempests. On the moon Io, Voyager captured images of active volcanoes spewing material hundreds of miles into the vacuum of space. It was the first time active volcanism had been witnessed on another world. Reaching Saturn in 1981, the probe's sensors showed that the planet's rings were not broad, solid bands. Instead, they were made of thousands of thin ringlets, kept in place by the gravitational influence of small shepherd moons. In 1986, Voyager 2 became the only spacecraft to reach Uranus. It discovered 10 new moons and measured a magnetic field that was tilted nearly 60 degrees away from the planet's rotational axis. The 1989 Neptune encounter revealed the strongest winds ever measured in the solar system, gusting at 1,200 miles per hour around a massive weather system called the Great Dark Spot. After these encounters, Voyager 1 turned back to take a final mosaic of the planets, the family portrait. It captured Earth as a single pixel of light, which Carl Sagan described as a fragile, pale blue dot, before the cameras were permanently deactivated. This decade of gravity-assisted flybys provided the evidence to see these distant points of light as they actually are: complex, geologically active, and violent worlds. As Voyager 2 moved into the deep void, it presented an engineering challenge: how to maintain a data connection with a 1970s transmitter that was quickly becoming the most distant object in the sky. Communication depends on the Deep Space Network. The 70-meter dish at the Canberra complex in Australia, known as DSS-43, is the only antenna on Earth capable of sending commands to Voyager 2. The signal returning from the probe is incredibly weak, less than a billionth of a watt by the time it reaches Earth. Traveling at the speed of light, those signals take nearly 20 hours to arrive. Successfully capturing these faint radio whispers allows us to maintain a tether to a machine that has now pushed past the boundaries of our solar system. The Heliopause is the invisible outer limit of the Sun's influence. It is the region where the outward pressure of the solar wind is finally stopped by the gas and plasma between the stars. This diagram shows the scale of the Sun's protective bubble. Voyager 1 breached it in 2012, and Voyager 2 6 years later. At 119 astronomical units, a sudden density increase provided physical proof the spacecraft had entered interstellar space. Voyager has now transitioned from exploring our neighboring planets to becoming humanity's first observatory in the space between stars. The mission is now facing a power limit. The radioactive plutonium batteries are decaying, losing 4 watts of power every year, and forcing NASA to shut down instruments to keep the spacecraft alive. Even after power fails, the probes carry a final payload. Attached to the chassis of each spacecraft is a 12-inch gold-plated copper phonograph record. The record is a time capsule. It contains 115 analog images, greetings in 55 different languages, and a collection of Earth sounds, from the songs of whales to the music of Mozart and Chuck Berry. In the coming decade, the transmitters will go silent, leaving the probes to drift through the Milky Way at 34,000 miles per hour. They are expected to survive for at least 1 billion years. Voyager 2 is our most distant archive, a physical record of Earth's existence that will continue traveling long after the